Okay, so let's get into this naming thing. So here I've got this list, 5 steps to go through. And you can see step number 1, start with the name of the ligand listed alphabetically. See table 22.3. That's this table right here. Okay, so this is kind of a weird thing. Normally in chemistry, we don't use alphabetical organization, but we do in complex ions. Okay. So we're going to use a prefix to indicate the number of each type of ligand. And we have to remember our Latin, di, tri, tetra, penta, hexa. And that would continue on hepta, octa, nona, deca, et cetera, et cetera. Okay. Typically, we won't see that go beyond 6. Right? And then now we write the name of the transition metal ion with a Roman numeral indicating the oxidation state. So for example, okay, we first start with the name of the ligand. So if we're looking at this example, nickel with 6 waters, okay, so we recognize because the water is 0, the water is not going to add any of the charges. So when we see that 2 plus, that 2 plus belongs to nickel. That's a nickel 2 plus, which we know is, we would write that as nickel Roman numeral 2. Okay? And so we start with the name of the ligand alphabetically. We use a prefix to indicate how many we have. So we have 6 waters. So that's going to be hexa, aqua, nickel, 2. And so you can see we don't smash the vowels together. There's 2 vowels in there. Hexa, aqua, nickel, 2. Okay, so now for the next one. So we can also remember that ammonia was a 0 charge ligand, so it doesn't add anything to the charge. So that 3 plus then has to belong to the cobalt, and there it is, cobalt 3. And there's 6 of these ammonias. We remember they become amine in the nomenclature. So that's hexaamine cobalt 3. Hexamine cobalt 3. Okay. So now what happens if we have 2? Well, remember, start with the name of the ligand alphabetically. Okay. So once again, we've got 4 ammonias and 2 waters. Neither of those add to the charge at all. So that is a copper 2 plus. And so there it is. There's the copper 2. And amine comes before aqua in the alphabetical order. So now that becomes tetraamine diaqua copper 2. And you really sound like a chemist when you can just like rattle this off. Tetramine diaqua copper 2. Okay. So what happens if our complex ion is negatively charged? Because you notice all of these complex ions are cations, okay? And remember, I said earlier, we can have complex ions that are positively charged, so they're cations, or complex ions that are negatively charged, as anions. And so with cations, we don't change the name at all. We just smash all these names together. We start with the ligand with the numerical prefix. We list the ligands in alphabetical order if there's more than one ligand, and then we indicate the name of the transition metal with the Roman numerals indicating its charge. Okay, so now if it's negatively charged, we add an 8 to the end of the name of the central metal ion to indicate that that complex ion carries a negative charge. So here's that this iron with cyanide complex ion, okay? And you can see now this one is rather complicated to work out. Okay, because we have to remember that each cyanide is 1 minus. So I'll put 6 CN minus, and we know that it made an FeCN6 3 minus. Okay, so in order for this whole complex ion to be 3 minus, it had to have started with an iron 3. Okay, so that is slightly different than that Prussian blue compound I showed you, right? That had an iron 2 central metal, and as a result is -4 charge. This complex ion, on the other hand, we recognize has an iron 3, even though it doesn't say that it's iron 3 plus in here, we have to deduce that it's iron 3 plus because we know that with 6 cyanides being 1 minus each, that's 6 total minus, the entire complex ion carries a negative 3 charge, so we had to have an iron 3 as the central metal. Okay, so that's going to go hexa, cyano, and then now the iron becomes ferrate. Okay, so I know that that gets confusing here. So we're going to say iron equals ferrate when it's the negatively charged. Another one to remember, copper becomes cuprate. Okay, so that one was a little confusing. And all of the other ones go as just their normal name. You just add an 8 at the end. Okay, so hexacyanoferrate 3. We remember the Roman numeral 3 tells us it was an iron 3 plus. The hexa tells us there was 6 cyanides, and the 8 tells me the entire complex ion is negatively charged. Okay, so let's do another example. So again, we have to be able to deduce the charge for this example, so I'm going to work that out right here. So we can see that I've got an iron. We don't know what the charge is yet. We've got an H2O, just one of them, and we know that's neutral. And we've got 5 cyanides that are all negatively charged. And this thing makes this complex ion that has a 3 minus charge. So the entire thing is negative 3. So that means this has to be an iron 2 plus because 5 minus 2 plus makes 3 minus. Okay, so we have to be able to work that out from the formula. So now that means we've got a ferrate 2 at the end. Okay, and now we've got to put these in the right alphabetical order. Aqua comes before cyano. So that's, and there's only one of them. So we don't say mono aqua. We just say aqua penta cyano ferrate 2. Aqua penta cyano ferrate 2. Okay. So let's do this last one, this aluminum, and let's work out the charge on aluminum. Well, first of all, I should say aluminum is always 3 plus in a compound. So in fact, we don't need to work it out because this is one of those rules. We remember that aluminum is always 3 plus. So you notice the Roman numeral 3 is not there. So when we have a transition metal that's always the same charge, we don't put it there because it's always the same charge. Okay. So now we have 2 waters. So that's diaqua. We have 4 hydroxides. So that's tetrahydroxo. The whole thing is minus 1 charge, and we can see that makes good sense because water is neutral. Each hydroxide is negative 1, and there's 4 of them. 4 minus plus 3 plus means this whole thing is negative 1. So now this is diaqua tetrahydroxo aluminate. Okay. It takes some practice. You're going to have to practice this with some flashcards. So now for the final step, okay, we list the counter ion first if it's a cation, list the counter ion last if it's an anion, and follow the rules for ionic compound nomenclature. So, for example, here's a whole bunch of things. I want you to stare at these for a minute. I'm going to stop this and I'm going to record a part C, but I want to see if you can work this out before I work through them. Okay? Go for it.